Today we will be looking at long division of polynomials and synthetic division. And our main focus would be on synthetic division. So first let's talk about long division. Long division is used to divide two polynomials. And these are the steps that we'll follow. So first you want to arrange the terms of both the dividend and the divisor in descending powers. Then we're going to divide the first term of the dividend by the first term of the divisor. Then we're going to multiply, subtract, and bring down our remainder. So it's really a lot like the same procedures we take when dividing a number by another number. So for example, if we have the number 1252 and we're dividing by the number 2, so if we have the number 1252 divided by 2, how many times does 2 go into 12? And so we say it goes in 6 times. 6 times 2 is 12. And then we're going to subtract. So 12 minus 2 is 0. And then we're going to bring down the 5. 2 goes into 5 2 times. So 2 times 2 is 4. And then we bring down the 1. So we get 12. 2 goes into 12 6 times. And so we get remainder of 0. So the 0 here is our remainder. Our 2 is our divisor. The result is the quotient. And the inside is the dividend. So we're going to follow those same steps when we're dividing a polynomial by another polynomial. Okay, so let's look at example 1. So we have x squared plus 5x plus 6. And notice that the powers are in descending order. So we have 2, 1, and then 0. And we're going to divide by x plus 3. So you want to ask yourself, what do we need to multiply this here to get an x squared? So I would need to multiply by an x. And so I'm going to have x times x is x squared. X times 3 is 3x. And then we're going to subtract. But when you're subtracting the entire polynomial here. So in reality, this is going to become a negative x squared since we distribute the negative here, and negative 3x. Okay, so I'm going to rewrite that as negative x squared and negative 3x. So x squared minus x squared is 0. 5x minus 3x is 2x. And then we're going to bring down our 6. And so now we ask the same thing. What do I need to multiply this x to get a 2x? So I need to multiply by 2. So 2 times x is 2x. 2 times 3 is 6. And then we're going to subtract the entire thing here. So we're going to distribute this negative. And we're going to distribute this negative, which is going to give us a negative 2x and a negative 6. So 2x minus 2x is 0. 6 minus 6 is 0. Okay, so our remainder is 0. Our quotient is x plus 2. Okay, so let's look at a couple of more examples. So we want to make sure that we write it in descending order. And then we're dividing by x plus 9. So in order to get an x squared, I will need to multiply by x. X times x. So we're multiplying these two. X times x is x squared. Plus x times 9 is 9x. We need to subtract. So what we're doing is changing the signs for both of these terms because we're subtracting the entire thing. X squared minus x squared is 0. 14x minus 9x is 5x. Bring down the 45. And now we ask ourselves, what do I need to multiply the x to get a 5x? And that would be a plus 5. So we get a 5x plus 45. We're going to change our signs because we're subtracting. And that's going to give us remainder of 0. So let's try the next example. So we have x squared plus 8x plus 15. So notice I rewrote it so that they're in descending order. And we're dividing by x plus 5. In order to get an x squared, I need to multiply by x. X times x is x squared plus 5x. We're going to subtract, so we need to change the signs. So we get 0. 8x minus 5x is 3x. Bring down the 15. So now we're going to need to multiply by a 3. 3 times x is 3x. 3 times 5 is 15. Change our signs since we're subtracting. So we get remainder of 0. So getting remainder of 0 is actually going to be a great thing, and you'll see why in the next few sections. The reason it's a great thing is because it tells us that x plus 5 is a factor of the polynomial, which means that we can set that equal to 0 and find our 0. Let's rewrite this in descending order. So we have x cubed. There's no x squared, so we're going to represent that with the 0. And there's no x, and then minus 1. So we're going to divide this by x minus 1. So in order to get an x cubed, we're going to need to multiply this by x squared. X squared times x is x cubed minus an x squared. Change our sign since we're subtracting. So that's a negative, that becomes a positive. And so we're left with x squared. Bring down our x. And now to get x squared, I need to multiply by an x. X times x is x squared. X times negative 1 is negative x. Switch our signs. Negative, positive. And so x squared minus x squared is 0. X plus 0x is x. Bring down our negative 1. Need to multiply x to get x. Well, that would be a 1. So 1 times x is x. 1 times negative 1 is negative 1. Change the signs so we get 0. So our quotient is x squared plus x plus 1. Okay, let's try the next one. We have 6x cubed plus 7x squared plus 12x minus 5. And we're going to divide this by 3x minus 1. So in order to get a 6x cubed, we will need to multiply this by a 2x squared. So 2x squared times 3x will give us 6x cubed minus 2x squared. Change the signs. So we get 0. 7x squared plus 2x squared is 9x squared. Bring down the 12x. So in order to get 9x squared, I will need to multiply by 3x. 3 times 3 is 9x squared. 3x minus times a negative 1 is negative 3x. Change our signs. So we get 0. 12x plus 3x is 15x. Bring down our negative 5. In order to get a 15x, we have to multiply by 5. So we get 15x minus 5. We need to change the signs. So that becomes a negative and a positive, giving us a remainder of 0. So we don't always get remainder of 0, but in these examples, we do get remainder of 0. Okay, so these were examples using long division. So now I'm going to do an example using synthetic division. And I'm just going to use this same problem here. So for synthetic division, we take the coefficients. So the number in front of x squared is a 1, so I'm going to write 1 here. The number in front of x here is a 5, so I'm going to write the 5. And then our constant is a 6. And then I'm going to draw this line here. And then for the x plus 3, we want to use x minus c. So we need to figure out what c is. So x plus 3, notice, can be written as x minus negative 3. So that would be the same. So our c is going to be negative 3. So essentially, if you see a plus 3, you're going to write the opposite, negative 3. So the first step in doing synthetic division is to bring down the 1, negative 3 times 1. Then we're going to multiply this number times this number. So we're going to multiply that. So after we multiply negative 3 times 1, we get a negative 3. So we're going to write it in here. And then the next step is to add these two numbers. So 5 plus negative 3 gives us a 2. So then we're going to repeat the same steps. So we're going to take negative 3 times 2. That gives us a negative 6. And then we're going to add 6 minus 6 is 0. Okay, so now to get our answer, we're going to look at this bottom part. Since you started with degree 2, then you're going to start with 1 degree less. So this number 1 is going to be your first term. So we're going to have x. Since the degree was 2, now this degree is going to be a 1. Then we're going to have a plus 2. So this is going to be your quotient. The last number is your remainder. The example to the left is using long division. Now we'll do synthetic division. So you want to write the coefficients of the dividend. So that's 1, 14, and 45. So that's the coefficients here. And then for x plus 9 for your divisor, we're going to write it as x minus negative 9. So we use the negative 9. So it's just opposite. If you have a plus 9, we use negative 9. We're going to bring the 1 down. Negative 9 times 1 is negative 9. 14 minus 9 is 5. Negative 9 times 5 is 45. Negative 45 plus 45 gives us a 0. So our quotient comes from these numbers. Since we started with x squared, then we start with 1 less, so we get x plus 5. And of course, this is our remainder. Okay, so let's look at these examples here. Okay, so let's do this problem using synthetic division. So the coefficient for x cubed is 1. There's no x squared, there's no x. Then we have minus 1. So here, since we're dividing by x minus 1, then we'll use a positive 1. So we bring down the 1. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. 1 plus 1 is 0. So our quotient, since we started with x cubed, we're going to go 1 less. So this 1 will give us x squared. This one is positive x. And then this one is your constant 1. So this is going to be your quotient. So one of the reasons that we want to use this process is since this gives us remainder of 0, then that tells you that this 1 here is a 0. But more importantly, it breaks this polynomial into a quadratic equation. And so at this point, you can use factoring or you can use the quadratic formula to find the rest of the zeros. Okay, so for this example, let's use synthetic division. So my coefficients are 6, 7, 12, and negative 5. In order to use synthetic division, your divisor should be in this form, x minus c. But notice here that you have a 3 in front. So one of the best ways to do this is going to be to use the long division. But if you want to use synthetic division, you still can do that. But you will have to take your divisor, set it equal to 0. We're going to add 1, divide by 3. So we get x is equal to 1/3. Then I would write the 1/3 on the left side. And so you can see that now it's set up in this format here. So on the outside, we would have a positive 1/3. So I'm going to bring the 6 down. 6 times 1/3 is 2. 7 plus 2 is 9. So we bring down the 6. 6 times 1/3 is 2. 7 plus 2 is 9. 1/3 times 9 is going to be 3. 12 plus 3 is 15. 15 times 1/3 is 5. Negative 5 plus 5 is 0. So you can see here that we still get the same remainder of 0. And so now to get our quotient, the 6, we're going to write with 1 less power. So instead of x cubed, it's going to be 6x squared plus 9x plus 15. So now that we have our quotient, if we wanted to find the rest of the zeros, then we would use quadratic formula here, or we would try to factor. And so in your 13-14 classes, you're going to learn how to use this method to find the rest of the zeros.